All right, so all right, so we were talking about so we start. Okay, now repeating everything. How many nodes here? So I will remove this 10k now. I will use mod v. So mod v, whatever is the number of words in your, what is this? What is mod v? If I have a corpus size equal to 1 billion, what is mod v? So mod v is not 1 billion. Mod v is the number of distinct words that you have in your corpus. So you might be having 1 billion words, but let's say there will be appearing 7 to 8% of the times. But in V you will be counting this only once. So V is nothing but the set of unique words in your vocabulary. Okay. So all right, now next. So what was the first architecture? So this has, this input layer had mod V neurons, the output layer has mod V. What about this intermediate one? You keep whatever you want, and we chose to keep this equal to 300. Okay. Now what was our training example? Our training example was fox, comma, quick. So what is the center word? Fox. What is the target word? Quick. So we said we will enter a one hot vector. Everywhere there will be 0 except at the place for fox, which we have been keeping to be 4000. Okay. And what do we want in the output? We want our model to output one hot vector corresponding to quick, in which there will be 1 at 6000 and everywhere else we will have 0. So we also wrote a cost function for it, right? What was that? What was the cost function? What was the cost function for this architecture? Right. So we wanted to compute the probability of target word given center word. Okay. So what we have here is so can I remove this? I think everybody now knows what is V. Okay. So okay, let me keep it. I'll write everything else there. Now what happens in the case of whatever we did yesterday? Neural network architecture remains the same. So I'll save the space here. I'll just write 6k. Okay. Now what happens for whatever we did yesterday? You have how many neurons in the first layer? How many neurons in the first layer? So we are mod V, keeping it mod V now. So mod V, what will be there in the next? 300 again. This is by choice. We want it to be 300. Okay, and this is mod V again. So whatever we did yesterday, how did we change this softmax to a combination of logistic regressions? What did we do? कल तो सब बड़े बोल रहे थे कि हाँ समझ में आ गया. Yes. No, so how does this architecture is impacted? Are we still keeping the same or architecture changes? All right. So I'm not. That will be there in the third figure. So how are we changing this softmax to a combination of zeros and ones that we talked about yesterday? We said for every neuron, right? In this case, what are we doing? In case of original skipgram model, where softmax was used, what are we doing? You are saying this is a classification problem, multi-class classification problem. This is my input and I want to output quick. But quick is only one of mod V possible candidates. Okay? So you guess for quick. If you don't get quick, you go and back propagate and so on. The problem, what was the problem here? What was the problem? Softmax. You are doing softmax for every example and the summation in denominator is huge. And you are computing that for every example. So author said even though this works, but this is so slow that you can't do much. Then they talk about this. What they say here is, instead of this long vector, so this is a one hot vector. What will softmax give you? So equally long vector, but every word will have some probability. And for things to go right, we want the probability in this case to be highest for quick. Now what they are saying, every neuron is going to output 0, 1. And how did we do that? Right. So instead of, so how did our objective change? How did our objective change? See, earlier what we were doing, now I need more space. So earlier what we were doing, we were computing the probability of output word given input word. This is what we were doing here. What are we doing here?
The word is available in our corpus or not?
So here we have changed the objective. Are we computing this probability anymore? No. What are we computing? We are saying given a pair. You complete? You complete? Given a pair what? Given a pair, you are supposed to guess whether this pair is coming from the corpus or it is not coming from the corpus. How many of you understand this notion of what does it mean by coming from corpus and not coming from corpus? How many of you understand this fact? So shall I repeat it once? Coming from corpus means whatever corpus you have, make pairs, and that is your pair of all, I mean that is the set of all pairs that are coming from the corpus. Every other pair is not coming from corpus. Which set is bigger? And how big is it? Close to mod v times, right? Roughly mod v times. That is huge. Okay. So because you see, for every pair you will have correct pairs of roughly, if your window size is 2, right? For every context pair, how many will come from corpus? Just 4, to this side, right? But how many will come from non-corpus? Mod v minus 4, right? So that is a huge set. For all 0, 1, 0, 1, so we have accomplished here one thing. Instead of doing a softmax, we are doing just this sigmoid here. How is this computationally efficient from that one? Because you are still doing things for all mod v neurons. So how is it more efficient?
We are not doing mod calculation for every 10,000 example. We are not doing mod v calculation, that was in denominator earlier. For every 10,000 example, for every mod v example.
Right. What was there in the numerator? What was there in the numerator, right? देखो, if you try to remember word2vec through equations, you will have a hard time doing it, right? What you should rather do is pick a word here. So what is this? Which vector is this? This is our v fox. We are using v for what? We are using v for the input embeddings. Okay. Now, do you agree that if this is fox, at the exact same number, there will be a u fox, right? And these two will be potentially different. Okay. Now, but there will be a v for every word, there will be a u for every word. You certainly don't. Okay. And you certainly don't want to compute fox comma fox. That will almost never occur unless you make a typing mistake, right? So what we are looking for here? U quick. So u quick will be somewhere here. So this is my u quick. And answer will be 0 or 1. How do you compute sigmoid? 1 upon 1 plus e to the power minus z. What is z in this case? Look here and you will be able to remember everything. Equation se yaad nahi hoga. So u quick transpose dot v fox. That will give you one number. Okay, that gives you one number. That is your z, and you compute the sigmoid. What was there in the numerator for this cost function? U quick transpose dot v fox. That means numerator you were anyway computing here as well. And when you go from here to here, you are not computing anything extra. You are just computing that quantity which was there in numerator. So this actually directly gets rid of your softmax. You don't have to do mod v summations anymore, and you are not doing anything extra compared to this thing. How many of you follow this? See, to compute whatever each neuron is doing, what are you still computing? Dot product of u with v. And this is something you were anyway doing. Previously in this cost function you had u dot v in the numerator anyway. And of course you were doing it for denominator as well, because there was a summation sitting before this dot product. You seem lost. Chalo. Okay. So is this fine? Authors go one step ahead. What are they saying? Now actually negative sampling comes in, because right now we are not doing any negative sampling. We are simply saying make all the mod v pairs, okay, say 0 for everyone else except for those which are coming from the corpus. Okay. So now what do authors say? Authors say you don't need mod v negative samples. So how should I draw this last one? There you should be able to help me. How many neurons in the first layer? Mod v. All right, mod v. Hidden 300. All right. What about the last one? Mod v. Right? And what are we saying in this case? We are saying you don't need what? In this case, so what is the difference between here to here, you know? What is the difference between here to here now? Sorry?
So, take balance examples of positive and negative sampling. So,
No. We are not kind of balancing in that sense. So choose k random negative samples. What does it mean? My original example was fox comma quick. Now what I am supposed to do? Let's say k is 5. So fox comma car, fox comma the, fox comma alphabet, fox comma alphabet is a word. Fox comma zebra, fox comma apple, right? And so on. So you create, let's say, 4 such negative samples. So what was the, let's say this is apple, let's say this is zebra, what more? Orange, this was quick, and this was car. So which are negative samples? Except quick, apple, car, orange, zebra. These are my 4 negative samples. And what authors are saying is just keep this. What advantage does this give me over this one?
how do we know that random example that has a quick in that?
No, random example does not have quick. This is coming from, so this is, I am deterministically taking from, so I have made all the pairs which are coming from corpus. So when I am talking about this particular architecture, I am saying fox comma quick is my training example. We are saying fox comma quick, keep that. Now choose 4 other words other than quick. I mean, it can be quick as well. Choose 4 words randomly from my set of vocabulary. Okay, so these words are randomly chosen, and quick has to be there because I am doing everything corresponding to this example in this iteration. More questions here? Excellent. How many of you agree? The dot product will always be 0. How many of you don't agree? There is only one dot product we are doing in this series of 5 lectures, 6 lectures, whatever. Why will that be 0? This whole thing? Is this whole thing 0? Is this whole thing 0? No. There is only one. So we have 1 here. And this matrix is the non-zero. So all these numbers are potentially non-zero. Some of them might be 0 because they are 0. Right? But we cannot claim that this is a non-zero vector. All all mod v minus 1 elements here are 0. So they get multiplied with everything to make that 0. But this guy is 1. When this multiplies with non-zero numbers, it doesn't give you a 0 vector. Remember, how do we compute vfox? W1 and then, so what are the dimensions of W1? 300 cross mod v. So this must be multiplied with a vector of size mod v. What is that? The one-hot vector of Fox. So matrix here, the weight matrix W1, which is of size 300 cross mod v. So you multiply that with one-hot vector of Fox. What will that give you? So we are, I just need some small space, which also I don't have. Okay, so let me do it here. What are the dimensions? 300 cross mod v. What are the dimensions of one-hot vectors? Mod v cross 1. And there will be a 1 at, we are seeing 4000 for Fox. Okay. So this is 300 cross mod v. So which part will get multiplied with this? See, this whole thing goes, right? And all this matrix is non-zero. Of course, if some things are 0, they are 0, but in general this is non-zero. So this element here, which one? Where one? 4000, right? So 4000 column. This particular column will come as it is here. Right? This is non-zero, so this thing is non-zero. Every other vector is 0. I mean, every other vector here is 0. Okay? Now coming back to this. So we know what we gained when we go from here to here. I hope everybody follows that. What are we gaining when we go from here to here? I mean, what are authors trying to do? Why do they not stop here and they want to do this one? As a computer scientist, as a computer science student, you can always easily say one thing. What is it? Computational. So instead of doing mod v something, you are doing only constant number of times. So a time complexity for whatever reasons which was mod v, order mod v, it suddenly reduces to order constant, which is a huge gain. Okay, what else? What else? See, if you train this thing now, okay, so if you train for this particular thing, yes or no, what is backpropagation going to do? It will update these 300 weights, right? When you are going to train it for this one, it is going to update these 300 weights. Done? And when you are training for this one, it is going to update the 300 ones corresponding to this one. So how many weights are you updating in one iteration? No. No. Mod V cross 300. Basically you are updating the whole matrix. Okay? In this case, you are updating it for only this one, this one, this one, this one, I mean, I don't know. This is the last one. Just this, everything else you are not touching. So earlier you were updating mod V cross 300 weights. Now you are updating only 5 cross 300. Much less compared to what you were updating originally. Right? So the whole algorithm, when you make a travel from here to here, becomes very efficient compared to this one. And you just do that. Any questions? So, can I get rid of this? I mean, no, okay, I don't need to do any such thing. ये too much है. Where do I shift this one? I don't know. Anyway, but this one I don't want here right now. So let us talk about this one. This was your, this you were doing for just, this you were doing for just one example, okay? And what you were doing? Right, what we were doing, summation so T equal to 1 to capital T, this gives me an iteration over whole corpus, and then for every center word in the corpus I am going to take minus C to C, so J equal to minus C to C and J not equal to 0. And then I am going to do log of probability Wt plus J given Wt. This makes sense? And then you were supposed to maximize this. Okay, there was 1 by T, fine. So there was 1 by T sitting here, and we are supposed to maximize this. Now, what comes corresponding to this guy? This one? How does this change? Which part are you changing? This P part. Okay. And instead of this, what do you have now? So this whole thing gets replaced by, let me write this whole thing. This whole thing gets replaced by which whole thing, by the way? log p this thing. Okay, this will be replaced by what? Summation w comma c d no, this whole thing gets replaced by this log sigma vc dot vw plus sigma I don't want you to see it in these terms because I prefer this one. So this P is being replaced by what? 10,000 sigmoids. Okay. So this log P given WT, what is Tj plus T, WT plus J, this whole thing becomes, this whole thing gets replaced by 10,000 sigmoids. Any issues here? Okay. These two things are written differently. They are coming from two different papers and hence two different notations. Okay. Now what happens here? Here what we have is very small thing. What is it? So instead of this, complete D bar, for every W comma C you have k negative samples. That's it. Okay. In fact, it is okay with me if you do everything. Right? So what is this whole thing doing? What is this summation W comma C in D? What does this mean? WC in D coming from corpus. So how many pairs in total?
4.
If my corpus has size 1 billion, then 4 billion. So this D has size for 4 billion. When you say W comma C, what does it mean? You are talking about every damn pair in the corpus. Okay. And when you are talking about this, you are talking about every pair in the non-corpus. But what negative sampling tells you? Keep this as it is. Keep this as it is, and for every pair W comma C, you are going to take K negative samples. So this whole thing will not remain this, it will become rather how many? Just K random samples. So this exactly like this summation में क्या हो जाएगा? नहीं. So instead of doing this so many summations, we'll need to rewrite it. Okay, I'm not doing that. So does this make sense? Because I think we are done with the most involved part of this course. At least it is so for me. Questions?
सर यहाँ पे जो आपने ये सेकंड वाले में बोला कि दिस कमिंग फ्रॉम ये बिलोंग्स टू दी और वो बिलोंग्स टू दी डैश, वो जो कमिंग फ्रॉम कॉर्पस है, तो वो कॉर्पस मतलब जो विंडो साइज ले रहे हैं, जैसे वो सेंटेंस लिया, तो वो कमिंग फ्रॉम कॉर्पस है या फिर वो पूरा जितनी वोकैबुलरी साइज है?
I don't get that. Say that again.
सर आपने बोला कि ये पहले वाले में कमिंग फ्रॉम कॉर्पस है, और टीचर ने बोला नॉट कमिंग फ्रॉम कॉर्पस. तो सर वो कॉर्पस यहाँ पे कौन सा कॉर्पस है? वो सेंटेंस का कॉर्पस है या फिर
There is only one corpus. What is that? The whole written text that you have, aggregate of all written text, that is your corpus. Okay. Now when you talk about pairs, how are you making pairs? You choose a window size. Okay. Now note that I am overriding symbols here. I was using k for window size. Now I have started using k for number of negative samples. These k's, they are independent, they don't have anything to do with each other. Okay. So for every pair, this is going to be 4 billion for our 1 billion corpus and window size equal to 2, but this is going to be huge. So instead of this, you choose only k negative samples per pair. So you choose for a pair and correspondingly choose. Now the question here is, what is the next question? No, leave this. Let's say we have written this mathematical thing. I mean, what you are going to do is, you are going to write this whole thing in terms of this, right? So you write this. Now this one plus I equal to 1 to k. So remember I had written this thing, this one. This was for your, this was for what? This was for your pair in the corpus, and corresponding to this there are k pairs that are in not corpus. So we had written that actually, okay, this one. So you just replace this whole thing by that there, or what you can do is isko replace kar do with this thing, exact same thing. Okay. So what will be there on the third side? Third side is summation. So 1 by t summation t equal to 1 to t summation minus c to c j naught 0, this thing, where quick will be replaced by w plus, I mean t plus j, and fox will be t. Okay. So fox will be t and rest everything is like this. Right. So what was my next question? Yes. What is the question we should ask next? I mean, you should have asked by now. How do you choose? So when we say random, what do you mean by random? So recently, like not more than 2 months ago, word2vec was given the test of time award by NIPS, which happens to be a very big conference. All right, so this is a very beautiful paper, that's all I can say. All right, next. So when we say random words, what do you mean by random now? Huh? Sorry? No. Dropout kahan se aa gaya? My question is, you are supposed to choose k negative samples and you are supposed to choose these k words randomly. What do you mean by random? So I have mod v words in my vocabulary. Should the probability of every word be 1 by mod v? Everybody agrees? Yes or no? Yes. How many of you agree? So you are supposed to choose k words. How do you choose them? So when I am choosing apple, am I choosing it this way? There are mod v words in my vocabulary. So the probability of apple being chosen is 1 by mod v. Probability of car being chosen is 1 by mod v. Probability of orange being chosen is 1 by mod v, and so on, because the probability is uniform for everyone. Does this make sense? How many of you are in favor of it? Against? Wapis? See, I am saying, so quick was the actual word coming from the corpus, but these other 4, they are randomly chosen, right? Question is, how do you randomly choose? Do you assign probability of 1 over mod v? So, do you assign probability of 1 over mod v for every word, or you do something else? This makes sense? Anybody sees anything wrong with this? No. Huh? Right, right. And what is wrong with this? They don't do this. Every line, every line of this paper is cryptic. So they don't do this. Why? How many of you read Shashi Tharoor's tweets? And if you don't read, but have you heard of his English?
Yes, sir.
Right? So he uses words that nobody has heard of. Now, how will you like if such words will have equal probability compared to words like the? You find it fair? No. So then what should you do? What do you like then? So there is yet another distribution. I mean, of course there are many distributions, but there is yet another distribution. What is that? Frequency. So English language has a very nice structure where the appears roughly 7 to 8%. Okay? So I don't remember top 100 words in English vocabulary, they appear half of the times in your big corpus. If corpus is huge, having billions of words, then 50% of the words will be just this: the, n, a, of. So all these top 100 words by frequency aggregate will occupy half of your corpus. So what you can do in this case now? I don't like this. Is everybody okay with this? They understood? Huh. So now how to choose K? So one is probability equal to 1 over mod v, and another one is probability equal to, so now let's say frequency. So let's say frequency of word wi is this. Okay, what will be there in the denominator? Summation over I equal to 1 to mod v f of wi. Make sense? Now this is probability of Wi being chosen. Make sense? You take example related to orange. इसका आंसर इसका हाँ इसका सम कर लोगे तो 1 आएगा मतलब mod v नहीं this is the total number of words in the corpus not mod v. This is basically so there appears let's say and frequency of first word can be more than 1. So this is not mod v, right? Exact corpus size, yes, not mod v. Okay, so this is not what do you want to say? Say it again. You will do that for me? For every word you will do this for me? See, do you need to attend every word manually if you want to do that? No? How will you do it without doing manually? We take this offline, okay, after the class. So this is another probability distribution. Does this make sense? Here in this case PWI is simply 1 over mod V, which is same for every word. In this case it is this. So how is this good or bad? By the way, they don't do this either. So what do? They say that there is a whole spectrum between uniform and frequency. So why do they reject this one? They say the appears just too much. Okay, so what was wrong with this? Here we said those words which almost do not occur in a corpus, they get the same probability as words like the. Okay, here we are saying words like the, they get overweightage. So out of every sampled 100 negative samples, you will sample the 7 or 8 thus. This means those words which are there in English are there in your vocabulary too. They will never be sampled because of the fact that their frequency is too low. So they will almost never be sampled. You don't want that. Why you don't want that? What is the goal of word2vec? What is the goal of word2vec? To learn word representations. If a word does not appear in this pair a lot of times, what does it mean? Its representation will not be good. By the very fact that this word was almost never there in training, how can you expect for this word to learn good representations? Okay, so what they say is, how can I rewrite this in terms of this? This whole thing to the power 0 divided by is the same. Can I write this like this? What is fwi to the power 0? 1. What is fwi to the power 0? 1 for every I. Okay, and you take sum over it, that gives you mod v. Okay, in this case it is 1. They say uniform mein you have this power 0, frequency mein you have this power 1. So what they choose is, they choose this power equal to 3 by 4. That amplifies the probability of underrepresented words, but that decreases the probability of overrepresented words. So what they do is, instead of, so the same formula but power becomes 3 by 4 now. So finally we decode everything. This EWI coming from this distribution is actually f of wi to the power 3 by 4 divided by summation I equal to 1 to mod v f of wi to the power 3 by 4. Enough for today? So I leave you with a question. So tomorrow we won't have a tute, we will have only normal class. So tell me, last question for you. What is wrong with this अपन ने जो भी किया? I mean last में everything was fine. Just this choosing negative samples. What is wrong with this? So word2vec in all its details is over. Okay, but we can still do some optimizations, and that is what we are going to do. I think tomorrow will be the last class on word2vec. Okay, that's it. Thank you. बोलो. एक सेकेंड इसको सेव कर दें तो मेरे को. नहीं, मैं भी हटा दूंगा इसको.